Hello friends, in a previous video we have seen the current mirror circuit using BJT. I repeat, current mirror circuit is very important for all the exams, that is for GATE, for engineering services, pre and mains, for civil services exams and for different public sector exams. So I have already discussed the current mirror using BJT in my previous video. So now we will be discussing the current mirror using MOSFET. The current mirror using MOSFET is exactly similar to the current mirror circuit using a BJT. We have two MOSFETs here, just like BJT. Like this, we have a voltage source here. This is resistance R. The drain terminal of this is shorted with the gate terminal. We have short circuited source terminals which are grounded. Fine. And this is the drain current of Q2. This is transistor Q2. This is transistor Q1. This is the drain current of Q1. So this is current I in this. Sometimes we call it as reference current. Fine. So now remember, in case of MOSFET, the gate current is 0 because of that insulating layer. So the gate current of a MOSFET is always 0. Fine. Now, if you see, this is the voltage VGS. We are assuming both transistors are matched. First, we will be considering case 1. Case 1, we will be assuming the aspect ratio of the transistor Q2 is same as aspect ratio of transistor Q1. What is this aspect ratio? This is W by L ratio of the channel. W is the width of the channel, L is length of the channel. So W by L is known as aspect ratio. So aspect ratio of transistor Q2 is same as the aspect ratio of transistor Q1. This is what we assume. We know what is the drain current. The drain current of a MOSFET is, that is ID is equal to that is mu n C naught x by 2 W by L. First of all, we will be assuming that both MOSFETs are operating in saturation. So in saturation region, the drain current is given by, that is mu n C naught x by 2 W by L into VGS minus V threshold whole square. This is the expression of drain current. Fine. So here the drain current, since W by L ratio is same, so we are assuming both transistors are matched transistors. So this will be same. This will be threshold voltage will be same. So drain current of transistor Q1 will be same as the drain current of transistor Q2. So for matched MOSFETs, we will be assuming that is mu n C naught x W by L for Q2 is equal to mu n C naught x W by L for Q1, and we will be assuming the threshold voltage of Q2 is same as threshold voltage of Q1. Fine. This is what we are assuming. Now, in that case, drain current of this transistor will be same as the drain current of this transistor. That will be same even if these parameters are same. Fine. So ID2 will be equal to ID1. So the drain current of this will be same as the drain current of Q1. Now, since the gate current here is 0, current in this direction is 0. Why? Because gate current in a MOSFET is always 0. So the current IREF must be equal to ID1. So the current IREF is equal to what? Drain current ID1. Therefore, the drain current of transistor Q2 will be equal to what? ID1, and that is what? Iref. So means this current. If I can find this current, then I will be able to find this current. So this current is the mirror image of this Iref. Because of that, we call this circuit as the current mirror circuit. Now, what is Iref? Iref can be obtained by applying KVL. I repeat, start from this voltage. If it is plus, write it plus. Apply KVL. Apply KVL to find this. Start from this voltage. This is plus V. Start with plus V. Now, if it is a voltage drop after that, write minus. For voltage drop, write minus. So that is Iref into R. Voltage of a node from where we start. If voltage of that node is positive, start with positive voltage. If voltage of that node is negative, start with negative voltage. Then go on moving in the direction of current. So current is going downward. So if it is voltage fall, plus to minus, because in resistance current enters at the positive terminal, or we can say the point where current enters into the resistance is the positive terminal of the voltage drop. So this is plus, this is minus, so voltage fall. When it is plus, write plus sign here. Then for voltage fall, write minus sign. For voltage rise, write plus sign. So from here to here, when you come here, voltage drop across this resistance is what? Iref into R. But you are coming from plus to minus, so that is voltage fall. So voltage fall has to be taken negative. I repeat, this is plus voltage, write plus sign. Then for voltage fall, write minus sign. For voltage rise, if it is from minus to plus, voltage rise, then you have to make that positive. But here you are coming through voltage fall, so minus. Then come via this path. Again you are coming to this voltage fall, so minus VGS, and come to ground. So you have to start from that node and come to ground. Fine. So that is your KVL in case of this type of circuit. This is equal to 0. So what will be Iref? Iref will be V minus VGS divided by R. So that means I can control current of this transistor by controlling Iref. Iref can be controlled by controlling either voltage V or voltage or resistance R. So that is how we can control the current of this transistor. So that is, since I2 is mirror image of Iref, so that is why we call this circuit as current mirror circuit. I hope concept is clear. We can take case 2 where these ratios are not same. Fine, but we will be assuming one thing. Their aspect ratios are different, but we will be assuming this is same except aspect ratio. This condition will be assumed to be same. Both transistors are made of the same material, so threshold voltage will be same, and this factor mu n into C naught x is called transconductance parameter, and sometimes it is denoted by Kn in some books. In some textbooks it is denoted by Kn with subscript n, transconductance parameter of n-type MOSFET, n-channel MOSFET. Sometimes it is written simply K. So it varies from textbook to textbook. But we call this factor mu n into C naught x as transconductance parameter. So transconductance parameter of both MOSFETs will be assumed to be same in this case as well. But aspect ratios are different. If aspect ratios are different, in that case, what do we get? Please see it carefully. In that case, W by L ratios is different. Then we can find the ratio of drain current. So ID2 upon ID1 will be equal to W by L for transistor Q2, W by L for transistor Q1. That will be the only difference. So you will be mentioning, you will be given in the exam. And there are a lot of questions based on this concept in GATE exam, especially in GATE exam 2019. there were so many circuits where W by L ratio of the MOSFETs were different. In current mirror circuit, there were many questions based on current mirror circuit in GATE 2019. You will find these questions are fully solved in my textbook, which is there on disacademy.com. You can get access to that. But I'm just letting you know this ratio is very important. Fine. So from here we get the relationship between drain current of D2 and D1. So ID2 will be equal to W by L Q2 W divided by W by L Q1 into ID1. And you know what is ID1? Gate current of MOSFET is always 0. So ID1 will be equal to what? ID ref. So ID1 is same as I ref, reference current. So I can write it directly here. W by L for transistor Q2 divided by W by L for transistor Q1 multiplied by I ref. And you know how to get I ref? I have already given you the expression. I ref is nothing but V minus VGS. We are assuming the gate to source voltage for this or both transistors is same. That is what the assumption I am having, divided by resistance R. That is obtained by applying KVL. I have already shown you that expression, right? So I can get the drain current of D2 Q2 by using this relation if W by L ratio of both MOSFETs are different. I repeat, this is very important concept which is used in different questions. Fine. So, but you don't have direct, the question on biasing directly where I could have used this, but this is one of the probable question, probable topic which can appear in GATE exam especially, and there is possibility in engineering services prelims as well. But this is more important for GATE. Reason being because MOSFET is emerging to be important topic for GATE. It is still not that much important for engineering services and civil services exam, but in GATE there are a lot of many questions based on MOSFET. So that's why current mirror circuit is MOSFET is important for GATE exam. Fine. I hope you will remember this expression. So just by remembering these concepts, you can solve all the questions based on current mirror circuit. I will again repeat, I will again request, just get access to my text on disacademy.com. It is free of cost. I'm not asking for any favor. You just get access to this. You will get all questions based on this on compound circuits. Fine. So this is all about current mirror using MOSFET. In my next video, I'll be talking about another current mirror circuit that is called Wilder current source. I think that's Wilder current source. Wilder current source will be discussed in my next video. So wait for my next video. Thank you very much for watching the video.